Hello, good mornings, my dear students. So from this video, we'll be studying the new chapters, okay? And new chapters is what we are going to study is about the new chapters is from the part of chemistry, that is chapter number 3. Okay, you can turn on the page number 33. Okay, the name of this chapter is atoms and molecules. Okay, so what are we going to study in this chapter? We'll be learning more here. Okay, so here you see in this chapter we will be learning this. The first part is our introductions. Okay, the first part is we'll be discussing about the introduction, then the law of chemical combinations. Okay, who give this chemical combination, what are the point under this law of chemical combination. Then we'll be studying the most important theory in the chemistry, that is called Dalton atomic theory, and then we'll be discussing the we'll be studying details about the atoms, and then details about the molecules and what is ion. Okay, then the chemical formulas of the compound, then the molecular mass and the formula unit mass. Okay, then the mole concept. So these are some topics that we'll be discussing in these chapters. Okay, so you have to be very clear about this. Okay, chemistry, these topics is a backbone. I would say this topic, the atoms and molecules, is the complete backbone of this chemistry. Okay, from these chapters, if you have clear about this topic, if you're clear about these concepts, okay, that means there will be no problem in the sections of chemistry. Okay, so at the very beginnings, okay, so you see, in the midst of early 6th century, the philosophers stated all the matter could be broken down into 4 basic substances. Okay, so this is not only the Greek philosophers. Okay, there was not only the Greek philosophers, but there was many Indian philosophers also who have given the ideas about these matters. Who have given the ideas about this? What is it? Matters. These matters. Okay, who have given these ideas about the matters? These matters. Okay, who have given the ideas about the matters? Okay, these matters. Who have given the ideas about the matters? Many Greek philosophers and Indian philosophers said that, okay, that all the matters might be made up of some the small particles. Okay, but especially the Greek philosophers in the mid of 6th centuries, okay, as early of the 6th centuries, many Greek philosophers gave it the ideas that all the matters could be broken down into 4 basic substances. What are the 4 basic substances? I have given this already in this picture, so you can see in this pictures. Okay, what are the 4 basic substances? That is water, earth, fires, and airs. Okay, that is water, fires, airs, waters, and earth. So these are the 4 basic substances that the Greek philosophers have given about it. Okay, but when it keep on further, when a scientist or a chemicians, okay, or a philosopher keep on researching about this, many more theories many more postulates were been introduced, and many more ideas has been introduced by the different chemicians or philosophers, or you can say scientists. Okay, so you see in the 5th centuries, okay, people start wondering that the nature of the primitive element, okay, and thought that there must be a thing that are still smaller than which is common in every substance. This make things deeper and discover the presence of the ultimate smallest particles. Okay, the ultimate smallest particles, that is called the atoms. Okay, so what does it say in this? And it's in the mid of 5th centuries. Okay, and the people start researching, people start wondering whether the element, the matters that is around us, if we keep on studying more deeper and deeper, there'll be some part where we cannot further be divided. Okay, where we cannot further be divided. This idea was once given by the ancient Greek philosophers also, by the name called Democritus and Lysippus. Okay, Lysippus. So these two scientists, these two philosophers have told that, okay, if we keep on dividing the matters further and further, if we keep on dividing the matters again and again, okay, a time will come, okay, a time will come where we cannot be further divided. Okay, then that particles, okay, that particles is what we call as a invisible particles. Okay, mean invisible particle or indivisible particle means we cannot further be divisible. Okay, he give this these particles of indivisible, but it was commonly known as atoms also. It was commonly known as atoms also. Okay, it was commonly known as atom, but that scientist was not popular at all, and we don't study much about them. Why? Because they just give the there was just a philosophical considerations. Okay, there was just a philosophical considerations, but there was no experimental work, and there was no valid experimental work was there that they have released out. Okay, so the atoms that are smaller than that are not visible by the naked eye. Fires, waters, earth also have their individual atoms which are connected with each other. Okay, now what after the Greek philosophers have told that all the matters are further broken down into four basic substances. Okay, and that four basic substances may be water, fires, or air. Okay, but later on there was another statement said that all this water, earth present in our universe, okay, are all made up by the smallest particle, and that particle is called as atoms. We will be dealing more details in the chapter topic called atoms. Okay, now you see, after this atoms, after atoms, the terms for the slightly bigger entities was coined. That term is known as a molecule. Right after the atom, there is atom is one of the smallest particles, which cannot be further be seen. But slightly bigger than that atom, we have one particle, and that particles, okay, that particles is known as molecules. Okay, what is molecules? Also, we will be discussing about this detail. But first of all, we will be discussing different law given by the different this is a Greek philosophers. Okay, this is a Greek philosophers who have given the ideas about it. Okay, so next, first of all, in this topic, the most detailed topic we'll be discussing about is a law of chemical combination. Law of chemical combination. What is law of chemical combinations? Okay, at the end of 19th century, the scientist was able to differentiate between the element and a compound. Okay, by the end of the 19th century, like 18 something, 1897, 1880, 1870s. Okay, in the end of 19th century, okay, many scientists start differentiating between the element and a compound. Okay, they start to differentiate what is element and what is compound. Okay, and at the very beginning, the two scientists called Antonio L. Lavoisier and Joseph P. Bross give two laws explaining that the chemical combinations of the element. These two elements are what? The first element is law of conservation of mass. Another law is law of constant proportions. Okay, law of constant proportion, and these two are two scientists. Okay, this is Antonio Lavoisier. We also known as the father of chemistry. He is the father of chemistry. Don't forget, he is always the father of chemistry. Antonio L. Lavoisier. Okay, Laurent Lavoisier. Okay, Antonio L stands for Laurent Lavoisier. Okay, and this is what Joseph L. Bross. Okay, so these two are two scientists who have given the law of chemical combinations. And under this law of chemical combination, how many laws we have? We have two laws. That is law of conservation of mass, and another is law of constant proportions. Okay. So this Antonio Lavoisier is commonly known as he is commonly known as a father of chemistry. So don't forget about it. Next, what is the law of conservation of mass state? Okay, law of conservation of mass. Okay, law of conservation of mass state that the mass of a closed system will remain constant in chemical reaction. In other words, a mass can neither be created nor be destroyed in chemical reaction. This was the first law formulated by the Antonio Lavoisier in the year 1789. In the year 1789, he was the first scientist who have given this law. Okay, so what does this law say? Okay, if there is a chemical reaction taking place, and during this chemical reaction, the mass can neither be created nor be destroyed. Okay, the mass, that is what it can be neither be created nor be destroyed. Now you see, this is the first example that you see. If you're burning the coal, okay, you're burning the coal in presence of oxygen. Okay, you're burning the coal in presence of oxygen. Okay, how much coal that you burn, okay, that much amounts of carbon dioxide will be producing. Okay, that much amount. If you're burning 1 kg of coal and in presence of like a gas, that is oxygens, okay, that oxygen, and you're burning this in presence of coal in presence of oxygen, that mass amounts of carbon dioxide only will be producing. You're producing 1 kg of, you're burning 1 kg of oxygen, and but coal, but there will be not like more than thousands of thousands kgs of carbon dioxide will be. It is not possible in this way. That means what? We cannot create them. Just by one thing we cannot create more than that, okay? Or you can say you cannot reduce them, you cannot destroy them also. Like example, if I say let me take an example, the first example that you see you're making a tea, right? You're making a tea, you're putting this 1 spoon of sugars you're putting a 1 spoon of sugars, okay, to make a tea. That must taste, the spoon that you have, the sugars, a spoon of sugar that you have put into the tea, that must taste, that must sweetness, okay, that you are going to get. You are putting a 1 spoon of sugar, that means you won't be able to get that what is that, as if that you are getting more than the sweetness, okay? So it is not possible also, okay? So that what does the law of conservation said, it wherever the chemical reaction take place, okay, how much chemical reaction, what types of chemical, whether it may be displacement chemical reactions, whether it may be exothermic chemical reaction, whether it may be endothermic chemical reactions, okay, different types of chemical reaction we have. In this chemical reaction you can neither create it or not destroy the mass, okay? That means what? If you are taking a food, okay, if you are taking a plate of one plate of just you're taking a plate of food, okay, then you cannot get energy, okay, you won't be able to get energies for like the amount that you are like, you cannot stay for more than 3-4 days, right? The amounts of energy that you have eaten in your stomachs, okay, that mass of energy only they will be producing. It is not that there will be no doublings or there will be no destroying, okay? So that is what it says. So you see here also, you see 2 hydrogen and 2 hydrogen means total 4 hydrogen we are reacting with the waters, okay? So total 4 hydrogen is combining with 2 oxygen atom. So when they combine with 2 oxygen, that means what? 1 oxygen will combine with another 2 hydrogen, another oxygen will combine with another hydrogen, means 2 molecules of water that we are going to get. That means if you are combining only 4 oxygens or 4 hydrogen and 2 oxygen, that means you will not be able to get 4 molecules of, you will not be getting extra molecules of waters, okay, or you will not be getting less molecules of waters, okay? If you are getting 2 oxygen and 4 hydrogen, that means what? You will be getting how much? 2 molecules of waters, okay? If you are creating 3 molecules of oxygen and you are combining with 6 molecules of hydrogen, that means you will be getting 3 molecules of waters, okay? So that is what is said. How many molecules, whatever the mass that you have allowed to react, that mass amounts of mass only you are going to obtain it, okay? That means you will not be getting any extra, okay? So next is what? Law of constant proportion. As we know, the compounds are properties, okay? As we know, the compounds are properties of a 2 or a more element. That proportion means the elements are present in a compound remain the same, irrespective of the method of preparation. Okay, now let me give a simple examples on that best topic. Now you see, you're putting 1 spoon of amol, okay, what we call amol, right? Everyday amol, and 3 spoons of sugars, okay, you're making a tea. Now second time you're putting in 2 spoons of amol, that means you're going to double it in order to make it more like a tea. That means you'll be doubling the spoons of sugar, right? That means if you're putting 1 spoon of sugar, 1 spoon of amol, that means you will be putting 3 spoons of sugar. And if you're putting 2 spoons of amol, that means you will be doubling. That means you will be putting 6 spoons of sugar. That means whatever the amount that you are trying to combine it, okay, they will always combine in a constant proportion. That means if, like you say, if you say, let's say 2 molecules of, okay, if you're combining, like, let's say I'm making for 1 person, okay, for 1 student I'm giving 3 3 chocolates. Okay, for one student I'm giving 3 chocolate. Okay, for 2 students also, for another 2 students I have to spend how much? 6 chocolate, right? So that is what is the constant proportions. That is what that if we talk about this, that means total ratio that I got is what? 1:3. 1:3. If I have 3 students, that means my how much chocolate I have to spend? 9 chocolate I have to spend. That means what? It will always combine whenever the element is combining to form a compound. Okay, whenever the element 2 or more elements are combining to form a compound, and that combination will always take place in a definite proportions. Okay, definite proportion. You see, thus according to law of constant proportion, a chemical substance always contain the same element in a fixed proportion by the irrespective of the mass. Now you see, in the previous topic that in the previous course we have learned that okay, two hydrogen when they combine, okay, with the oxygen, that means how much molecules of water that you got? Only 1 molecules of water that you got. Okay, how many molecules of water that you got? Only 1 molecules. If I combine with the 4 molecules of hydrogen, okay, that means what? I have to combine 2 molecules of oxygen. I have to let it 4 molecules of hydrogen. That means we can say 4 molecules of hydrogen. That means what? 2 into 2 become 4. So if I let to combine 4 molecules of hydrogen to combine with oxygen, that means how much molecules of water that I will get? 2 molecules of water that I will get. Okay, 2 molecules of water that I will get. Okay, that means 2 molecules. You see, only one oxygen, 2 hydrogen, 1 molecules of oxygen, waters, 2 hydrogens. Okay, that means total 4 hydrogen and 2 oxygen. That means I will be getting 2 molecules of waters. Okay, that is what it said. Thus, this law of constant proportion is also known as this law of constant proportion is also known as a what? Definite law of definite proportion. And this law was introduced by the Joseph L. Prost. Okay, and the first law was the law of conservation of mass was introduced by whom? The law of conservation of mass was introduced by the Antonio Lewis-Burke. Okay, and this law was introduced by whom? This law was introduced by this law of constant proportion is introduced by whom? Joseph L. Prost. Okay, studied in compound, the elements are always present in the definite proportion mass. Okay, that is a statement. And a compound. Okay, this is your definition. What does the law of combination state? Law of constant proportion state that okay, in a compound, the elements are always present in a definite proportions of mass. Okay, so these are the 2 laws that we have learned. The first law is what? Law of conservation of mass. Second is law of constant proportion. Law of conservation of mass stated mass can neither be created nor be destroyed. Law of constant proportion stated in a compound, the elements are always present in a definite proportion by mass. That means if one object combined with 2 molecules of two substance, that means another object will also combine with 3 the bowling, that ratio will be there. Okay, constant ratio will be there. Okay, now you see the most important topic is that Dalton atomic theory. Okay, what does the Dalton atomic theory says? Okay, Dalton atomic theory is one of the challenging atomic theory that has been produced by the Sir John Dalton. Okay, so Sir John Dalton's what happened after the law of chemical combination, then there come a Sir John Dalton. He took a challenge to come up with a proper explanation for this law. Okay, this was taken by the British chemist. He was a Britisian, so called Sir John Dalton. He picked up the ideas of divisibility of matter and said that atoms are smallest particles of matter which cannot be further divided. Okay, he provided a theory based on the law of chemical combination and gave a successful explanation for these 2 laws. Okay, at the very beginning, the 2 laws which has been defined by the Antonio Lewis-Burke and Joseph L. Prost. Okay, there was not a complete explanation was there. Okay, not complete complete proof was there. But after this, when Sir John Dalton, he took out the Dalton atomic theory. Okay, in this Dalton atomic theory, the John Dalton was the first scientist who coins that the atom. Okay, the atom is what? Atom is don't forget this one. Atom. What is the atom? Atom is the smallest particles of a matter which cannot be further divided. Okay, divided further. Okay, it is indivisible. Second, atom you cannot further divide it. Okay, so he, based on this Dalton ability, he have given some 6 to 7 postulates about it that we'll be learning about. So this is our Sir John Dalton who have given the theory about this. Okay, so what is that theory said? We'll be studying in the next topic. Okay, so you see, this is the top. You see that the postulates of the Dalton atomic theory, that is what he have given. All the matters are made up of a tiny particle, and these particles are called atom. Whatever the matters present surrounded you, okay, whatever the matters that is surrounded you, and all these matters are made up of what? Whether it is a pencil, whether it is a pen, whether it is a book, notebook, table, chair, whatever it is, okay, and the living organisms or whatever, all this, okay, all these matters with the surrounding, okay, even the ear, okay, all these matters are made up by the tiny particle, and that particle is called what? Atom. This is the first point that you have to remember. Okay, second point is that atoms cannot be further divided. Atoms cannot be, second point, what is that? Atom, you cannot further divide them. Okay, you cannot further divide them. Means if you take a piece of a chalk, okay, then you try to grind it, then a time will come where you will not be finding any piece of a chalk, right? So you cannot further divide them again anymore, right? So that way, atom, you cannot further divide it. Okay, you cannot further divide it. That means they are indivisible. That means you cannot, they are indivisible, means they are not further divisibles. Okay, the atom said that atom you cannot create also, you cannot destroy also in a chemical reaction. Whatever the atoms are there, you cannot further destroy them, or you cannot further create them. Okay, all the atoms of the elements are identical in all respect, including the mass, chemical properties, and etc. Let's say we are taking two atoms. Okay, let's say this is a hydrogen atom. Okay, and let's say this is another hydrogen atom. Okay, this hydrogen atom, let's say this is a 2 atom. Okay, this hydrogen atom will have, okay, they will look very similar. They are very identical to each other. They're very similar to each other. Okay, these hydrogen atoms and this hydrogen atom, they are very similar to each other. Either in the mass also, their weight will be same, so their chemical properties will be same. Okay, but all atoms of different element, if the elements are different, let's say you are taking an oxygen, let's say this is carbon, let's say carbon. Okay, you are taking a carbon, and then you are taking an aluminiums. Okay, then you are taking silicons. Okay, so these 3 element or 4 element that we have on the screen, okay, let's say 1 2 3 4, these 4 element we are taking, and these 4 element will be different from each others. Okay, carbon will have different chemical property, aluminum will have different chemical property, silicon will have different chemical property, hydrogen will have different chemical property. Okay, so that is what the Dalton atomic theory said. That the 4th point, Dalton atomic, the 5th point, Dalton atomic theory said all the elements or all the atoms of different element will have different mass and chemical property. Okay, but atoms of same element, hydrogen atoms and another hydrogen atom will look same, their mass will be same, their chemical property will be same, and they will be totally similar with each other. Okay, but atoms of different element combine in a small whole number ratio to form a compound. Okay, what does it say? We see H2O, okay, hydrogen and waters. Okay, so this hydrogen and waters, okay, hydrogen and oxygen will combine. Hydrogen and oxygen will combine with each others, okay, in a definite proportions, okay, with a whole number. That means 2:1. Okay, here what is it? Their ratio is 2:1, and 2 is the whole numbers, and 1 is also whole numbers. You will never find that 2 atoms are combining in 0.5:7/2. You will never find this in this way. Okay, in this way you will never find in this way. You will never find this point ratio. Okay, you will never find in a point ratio. The atom will always always combined with another element in the form of whole numbers only. Okay, in a compound, the relative number and the types of atoms are constant. Okay, whatever the given compound is, whether the compound is hydrogen, water, is whether the compound is carbon dioxide, whether the compound is ammonia, or whether compound is whatever the compound is just, okay, all of them compound are have a relative number and the types of atoms are always constant. Remember this one. Okay, so these are the some postulates that you have to remember. The first postulate said all the matters are made up of tiny particle, and that tiny particle is called atom. Second is what atom cannot be further divided, but that is why the atom is and that is why atoms are known as indivisible. Atoms cannot be created nor be destroyed in a chemical reaction. All the atoms elements are identical in respect, including the mass, chemical property, etc. Okay, atoms of different element have different mass and chemical properties also, but atoms of same element will have same chemical property and same mass. Okay, same masses they will be having. Okay, so this is some of the postulates that you have to remember. Next, okay, now let's compare with the two chemical reaction, the explanations of the law of chemical combination using the Dalton atomic theory. The law of conservation of mass. Okay, the matter is made up of atom. That is law of conservation of mass said that mass can neither be created nor be destroyed. Okay, so this law, okay, it's completely similar with our postulate number 1. Okay, and our postulate number 3. Okay, in a postulate number 1 said the matter is made up of atom. Okay, and postulate number 3 said it is neither can be created nor be destroyed. This is a comparison between the law of chemical combination and Dalton atomic postulates. Okay, theory postulate, the postulate of Dalton atomic theory. Okay, so if we compare them, the law of conservation of mass, okay, the law of conservation of mass, and if we compare with the Dalton atomic theory postulate, this postulate number 1 and postulate number 3 are quite similar with each other. That is quite similar with the law of conservation of mass. Example, you see 100 grams of mercury oxide which heated in a closed test tube decomposed to produce only 92.6 grams of mercury and 7.4 grams of oxygen. So if we add up these two, that means you will get 100 grams. That means 100 grams of mercury oxide, if you try to heat it in a closed test tube, okay, then you will get a 92.6 grams of mercury, but 7.4 grams of oxygen will be releasing in the form of gases. Okay, so if you combine 92.6 plus 7.4, that means your total also, it is whatever the product that we are getting, mercury and oxygen, that is equal to 100 only. Okay, the next is what law of constant proportion. Is this law for directly postulate of 6 and 7? That is what that 6 and 5, which stated atoms of different element combine in whole number and a ratio and from a compound, and a given compound the relative numbers types are constant. So this postulate, this number 3, this law of constant proportion is quite similar with the postulate number 6 and 7. Okay, so you have to compare with this. Next, we'll be talking about the atoms. Okay, what is an atom? You see, atoms, you might be seeing the building block of n hills are small sand particles. Okay, you might have seen the n hills, like you might have seen the house of the n. Okay, and house of the n's are made by the sand, the small particle sand. Okay, similarly, you might have seen the building block of the building block. Okay, you might have seen the building, and the buildings are made by the like brick, right? So bricks are the building block of buildings. Okay, so they are made by one brick and another many more brick combined. That means you will get a building block. So similarly, like a building block, like a brick and a small particle, sand particles. Okay, similarly like this, atom is also a building. Atom is commonly known as a building block of a matter. Okay, that atom, one atom combined with another atom, that means form a molecules, and more molecules compound, and then they form a compound, and then more and more compound, that means complete structures of matter that we get. Okay, like carbon dioxide. In a carbon dioxide, carbon elements and oxygen element combined, then we produce a carbon dioxide. Then the carbon dioxide is also a matter, right? So Atoms are indivisible particles that cannot be destroyed nor be created by chemical means, that means chemical reaction. According to Dalton, all the matters are made of a tiny particle called atom, and this means that the rod of iron is also made of millions atoms of iron. Okay, and the rod of iron that you have in your home, right? And these irons are made by the millions of atoms of iron. Okay, million atoms of iron, million small atoms. Okay, they combine, atoms of iron, they combine, and then they form a complete structure of rod, right? So size of the atoms are very small. Okay, they are not visible with our naked eye, but can be seen with the optical microscope, the powerful optical microscope, and the size are mostly indicated in the atomic, the size. Okay, the size of the atoms are mostly indicated by the radius, and that is what we call atomic radius. The size of the atoms. Okay, don't forget this. What is the atomic radius? The atomic radius is indicated by the size of the is indicated by the radius of the atom, and that is called atomic radius. It is often measured in nanometers. Okay, nano means very small. Nano means very small. Okay, atom cannot be seen with the naked eye. However, the users of modern technologies have been able to see the surface of atom. The magnified image of surface of silicon atom is I'm sorry, I have forgotten to pick the pictures. Okay, so next is, you see, amongst all those elements, hydrogen atom is one of the smallest atom. Okay, don't forget this. What is the smallest atoms of all the elements? Hydrogen atom is one of the smallest atom. Okay, you can see the pictures here, the diagrams out here. Okay, hydrogen, the size of the atomic, then this much small it will be. That is 0.037 nanometer, means how much small it will be. Nitrogen, it will be almost 0.074. Iron is 0.126. Okay, nanometers. So this is the size of an atom. Next, you see, right after these atoms. Okay, now you see we have now commonly we have how many elements? We have more than 100. We have nearly more than 115 elements in our universe. Okay, so during that time, okay, during those time, there were very little element was being discovered. Okay, and they try to put the representation. They try to symbol like hydrogen, I'll make a symbol like this. Okay, phosphorus, I'll make a symbol. Copper, I will make a symbol. In this way, they were trying to represent. Okay, Dalton was trying to represent all these elements. Okay, but since time again and again, many scientists started researching about a different element, and then many more element was being discovered, and they was totally fed up of giving the symbols, that is. And another disadvantage of this symbol is what? Okay, they cannot further, like, it is impossible to draw about this. Okay, Dalton was the first scientist to use symbol to represent different element. Every symbol he proposed also represent a definite quantity of this respective element, and the symbol of some common elements are proposed by the Dalton are shown in the figures. Okay, so these are some Dalton symbols. Okay, now you see, this is a modern symbols of the element common. Some common element are given in the following table. This is some common element that you will see. Okay, aluminums are mostly denoted by Al. It is very convenient to write, right? It is very convenient to write. Argons are denoted by Ar. Bariums are denoted by Ba. Borons are denoted by B. Bromiums are denoted by Br. Calciums are denoted by Ca. Carbons are denoted by C. Okay, in this way, many more elements are been, many more than 115 elements are there, and for the 115 element, we have different chemical symbol. Okay, for different chemical element, we have different chemical symbol. Okay, so how does the chemical symbols get? How can we give the symbol to those elements? That we will be studying the rule. Okay, you see, at the very beginning, if you come across this one, aluminum, the aluminum A, the first letter is always capital and second letter is always small. That means this is one element. First letter is always capital and second letter is small. That means what? It is a one element. B is capital, A is small. That means it is a lowercase. That means this is one element. But some element, if you see, there's only a capital letters, that is uppercase only. It is only present in the uppercase. That means this is also one element. Okay, so how we are going to write about this, that we will discuss in the here. Okay. This is a rule that we are going to write during the chemical symbol. Okay, the first letter of the symbol is always capitals. You see hydrogen, the first letters. Okay, the first letter we will try to write it, this first letter, that is hydrogen, H. Okay, then helium. Okay, then we have already given H to the hydrogen. That means if we write again H to the helium, that become difficult. So what shall we write? Is the first letter I will write H. Okay, since H is already denoted with the hydrogen, so if I write the H for helium also hydrogen, that means there will be conflict between the hydrogen and helium. Okay, so in order to make it more like to distinguish between the hydrogen and helium, okay, so we write it He, that means the second letter of helium, that is He here, He, and we don't write He in this way. We don't write this He in this both the capital. We cannot write this one. Okay, so if we write this one, okay, that means the chemical symbol is wrong. So what we have to write, the first letter, if we write the first letter, if we write it, that is a rule that every first letter should be a uppercase. That means always capitalized. Okay, it will be always a capitalized. Okay, so it will, every letter, first letter will be capital. If you see, the first letters are all capitals only, and second letters should be always a lowercase. The second letter is always a lower case. Okay, second letter is always, I mean, this the letter that come after that if you are trying to write like helium, that means I have to distinguish from the hydrogen helium. That means I have to write He with the helium. That means the second letter E is written as a lower case. Okay, that means small letters. Okay, no element have a permanent symbol with more than 2 letters. Okay, no element you will get, not a single element that you will get at HEL or let's say LIT. Okay, there will be only 2 letters in it. Okay, there will be only 2 letters in it. Okay, there will be only 2 letters in it, so no letters. Okay, there will be no letters in it. Okay, there will be no 3 letters will be there, not more than 2 letters will be there, I'm sorry. Then one element, if the chemical symbol represent 1 atoms of this chemical, HN represent only 1 atom. If this N represent only 1 atom, this BN represent only 1 atom, this O represent only 1 atom. So, okay, O means oxygen, that means O, capital O, that represent. We don't write oxygen, we don't write the small letter 1, we always write the capital letters. Okay, we always write the capital letters O. Okay, so and we are writing about a nitrogen, that means you don't have to write nitrogen as N small letters. It is not like this. The nitrogen should be always capital letters. So if I write this one only a single letter, that means it is only a single atom. It is only a single atom. Okay, so we'll discuss more again detailedly about the how to write all those chemical element. Now you see, we have talked about the hydrogen. That means first we have given H to the hydrogen, that means, and then helium, then also start with the H. So in order to distinguish between hydrogen and helium, then we added E. Okay, then we come a lithium. Okay, lithium, so we write the first letter L. Okay, then we write it in the second letter, that is I, that is in the small letter form. Okay, similarly beryllium. Okay, beryllium, the first letter B is capital, second letter that E is what is it? E is in small letters. Okay, similarly boron. Okay, boron, capital letter B. Okay, so we have written the first letter B. That means boron, in order to make it not to get conflict with the boron and beryllium, we have written that boron. Okay, in boron we have written B, capital B, but beryllium we have written BE. Okay, so next we have a carbon. Okay, carbon, you have a carbon. So carbon, you have a carbon, that is what you talk about the carbon. Here we have written the C letters. Okay, carbon is also written as a C letters. Okay, nitrogen we have written N, oxygen capital O. Okay, the first letter capital O, fluorine capital F, neon capital N, nitrogen, and nitrogen N is already written with the nitrogen, so I have to, in order not to get conflict with the nitrogen and neon, I have written Ne. Okay, sodium again, you see sodium, it is, you see here we have a letter S, but our chemical name is Na. Why? Because the sodium is not an English word. Okay, the sodium is not derived from the English word, it is derived from the Latin words. Okay, and that Latin is what we call as a natriums. Okay, natriums. Okay, what is it? Natriums. Okay, what is that? Natrium? N A T R I U M. This, okay, this sodiums, okay, this sodiums is derived from the Latin word that is called natrium. Magnesium M, and then A, it is become difficult, so we write it Mg. Aluminiums Al, silicon Si, okay, P, phosphorus capital P, sulfur S, chlorine, okay, chlorine Lc, and the third letter that is L, that means second letter we are coming, that means it will be small letter. Argon Ar, okay. Potassium, again here P is capital letter, but we are writing with potassium starting with P, but we are not denoting this potassium with P, so we are denoting by K. Why? Because this potassium is also, the element potassium is also does not derive from the English name, but it is derived from the Greek name that is called kalium. Okay, that is what we call kalium, Greek or Latin. So that is what we call kalium, and that is why we write the first letter that is called K. Okay, sodium is derived with the Na, that is natrium. Okay, then potassium is derived from this Greek or Latin name that is called kalium. Okay, so that is K. Then calcium Ca. Okay, similarly we have iron. Okay, so irons are not denoted as I. Irons are not denoted as I. If you denoted iron by I, that means this is what, this I is not an iron. Okay, this I is not an iron. Instead, I denote for whom? I denote for iodine. I denote for iodine. I denote for iodine. Okay, don't get confused. I denote for whom? Iodine. Don't write iron by I. Okay, don't write I as iron. So iron is denoted by Fe. What is Fe? This is also not a Greek English word. Fe is what? It is a ferrous. Okay, ferrous. So it is known as a ferrous. Okay, so this is your Greek name. Okay, so this is what we call as a. Similarly, in this way we write, if the element is not deriving from the English, that means with what word you are deriving, that name we have to give. Okay, similarly, like in a recent time, in the early time, like wherever the element was been like discovered, if the element is discovered in a mole, okay, and that name, let's say you are giving some name, that means you are giving any name like pencil. Pencil is derived, a pencil element is derived from the mole. Okay, so what cell is doing is that pencil is denoted by M or according to the place name. Okay, so similarly different element was given for a different name. Okay, so that is all about the chapters of this topic up to the chemical symbols. Okay, writing the chemical symbol, and from next class we will be studying about the atomic mass and molecules. Okay, and we will be learning about the chemical, how to write the chemical formulas in the next topics. Okay, so I want all of you to be very serious and go through this, and I will be giving this I'll be giving all this PDF file, so you can go through this PDF file, so you can make a notes of it. Okay, so anyways, that's it. Thank you.